Hello everyone, welcome back once again to the DPS online learning platform. Today is day 5 of chapter 1 Real Numbers. Today we are going to begin with the first topic, that is how to find out HCF, also called GCD, and LCM of two or more positive integers. As you have already seen how to find out HCF of two positive integers by using Euclid's division algorithm. And in that Euclid's division algorithm, we have applied Euclid's division lemma. Now today, by using this method, we are going to find out HCF as well as LCM of two or more positive integers. You can use this method to find out HCF and LCM of two integers also, and more than that also. But before starting this method, let me explain you first of all that a number can be expressed in the form 2 to the power 3, where 2 is the base, 3 is the power, also called exponent, also called index. Second thing which you must know is what are prime numbers, what are prime numbers, and what are composite numbers. Now before beginning this part, let me first of all write down that natural numbers greater than 1, make sure that prime numbers and composite numbers cannot be 1. So let us take natural numbers greater than 1 like 2, 3, 4, 5, 6, 7 and so on. Let's write down few numbers. Let's start with the first number 2. But before that, let's define what is the meaning of prime numbers. Prime numbers are all those natural numbers greater than 1 which is only divisible by the number itself and 1. Number itself and 1 we have to check. Let's start from the first natural number greater than 1, that is 2. 2 is divisible by 2 and 1 and no other number. So that's why 2 is a prime number. 3 is a natural number more than 1 which is divisible by 3 and the 3 and 1. So that's why 3 is a prime number. 4 is divisible by 4 and 1, but apart from 1 and 4 and 1, it is also divisible by 2. So that's why 4 is not a prime number, it's a composite number. 5 is divisible by the number itself and 1. So 5 is a prime number. Let's take 6. 6 is divisible, see, every number is divisible by itself and 1. But if a number is divisible by other than 1 and itself, it's a composite number. Like 4 is divisible by other than itself and 1, that is 2. So that's why 4 is a composite number. 6 is a composite number. 8 is a composite number, and so on. Or we can say this way: all natural numbers greater than 1, out of these numbers, natural numbers, all numbers which are prime numbers, if I exclude all those numbers which are prime number, the remaining number which are left here are composite numbers, we can say. So I hope I made myself clear that prime number is are natural numbers greater than 1 which are divisible by itself and 1 are called prime numbers, and numbers which are divisible by other than itself and 1 are called composite numbers. And 1 is neither a prime number nor a composite number. So now let us come to the topic how to find out HCF and LCM of two or more positive numbers by using prime factorization method. So let me take one example first. Like, let's take numbers 144, three numbers 144, 180 and 192. Now as we are using prime factorization method, so first of all let us factorize these three numbers 144, 180 and 192. So I begin with the first number, that is 144, and let us factorize. 2 7 are 14, 2 2 are 4, 2 3 are 6, 2 6 are 12, 18 times 9, 3, 180, 90, 245 jar, 315 jar, 35 jar, 505. So you all know this, okay? You know how to factorize prime factors. 2 9 jar 18, 2 6 jar 12, 2 4 jar 8, 2 8 jar 16, okay? And 2 3 jar 6, okay? Now 144 can be written as 2 to the power 1 2 3 4 into 3 to the power 2. 180 can be written as 2 square into 3 square into 5 to the power 1. If you don't write 5 to the power 1, then also it's assumed to be 5 to the power 1 only. 192 can be written as 2 to the power 1 2 3 4 5 6 into 3. So let us see what is HCF and LCM of these three numbers. Now first of all, before writing HCF and LCM, let me first explain you. When I am going to write down the answer, that is HCF of these three numbers, that number should divide all the three numbers completely, exactly. Means that after division the remainder should be 0. Means we can say that HCF of three numbers is that number which exactly divides all the three numbers. And when I say LCM is that number which is divisible by all these three numbers. So how to find out? Just note down here, everyone. What you'll do, just note down here. I'm just erasing this part. What you do? Now tell me, 144 is factorized and written as 2 to the power 4 into 3 square. 180 is written as 2 square into 3 square into 5. 192 is 2 to the power 6 into 3. Now just tell me the prime factors. You just try to find out the prime factors here. Now tell me, in 144, which are the prime factors which has been used here? It is 2 and 3. Okay, write down this way. In 180, which are the prime factors we have used here? It's 2, 3 and 5. In 192, which are the prime factors we have used? It is 2 and 3. So when you are writing HCF, just note down. When you are finding HCF, try to find out in all the three numbers that prime factor which is common in all the three numbers. Common in all the three numbers. I am talking about these three numbers. So which is that prime factor which is common in all the three numbers? It is 2. So write down 2 here first. Into. Which is the other prime factor? It's 3. 3 is present in all the three numbers. Just check. Now, do you find that 5 is present in all three? No, not at all. So, we will not write. I mean, in HCF part, we will not write 5. Now, see, next. Still, it is left. Now, just see. In LCM. In LCM, what you do? Write down all the prime factors you can find here. You just see here. Now, tell me, what are the all prime factors which you find here? It is 2. It is 3 into. It is 5. So it is 2 into 3 into 5. Now just see. In order to find out HCF of these three numbers, now tell me which is the least power of 2 in all the three cases. Which is the least power of 2? The least power of 2 is, if you compare, it's 2, 4 and 6. Which is the least number? Which is the least exponent? It's 2. I repeat, which is the least exponent in the power of 2? In the power of 2, which is the least exponent? If you compare in the power of 2, the least exponent in all the three numbers, 2, 4 and 6, which is the least number in out of all these three numbers, 2, 4 and 6? It is 2. Now, let's take the second prime factor, that is 3. Now, 3 to the power what? Now, tell me exactly the same way, which is the least power. When you have to write down the power of 3, check again the least power of 3 in all the three cases. The least power in all the three cases is 1. So it will be 3 to the power 1. So what is the answer here? It is 2 to the power 2, which is 4. 4 3 is 12. Now just look here, everyone. which is the greatest power of 2 in all the three cases? It's 6. Which is the greatest power of 3 in all the three cases? It's 2 only. Which is the greatest power of 5? It's 5 to the power 1. So what is the answer? We are finding that 2 to the power 6 is 64. This is 9. 5 is 45. Multiply 5 4 is 20. 5 6 is 30, 32. 4 4 is 16. 1 4 6 is 24, 25. So it is 2880. Now just try to everyone understand the answer. Let's try to see the answer and let's compare, derive the relationship here. We are finding that 12 is a number. When we are saying that HCF of these three numbers is 12, means 12 is a number which exactly divides 144. It exactly divides 180. It exactly divides 192. And this HCF, when we say HCF of these three numbers is 2880, means this is that number which is exactly divisible by 144, 180, 192. Make sure everyone. So this is the way how you can determine the HCF of two or more integers. Okay. So I'll just take one more example. Okay, so that it is more clear to you all. Let me take the second example where I will be using two numbers. Okay, I will be using two numbers, that is 90 and 144. Now let us factorize 90 and 144. So we have and 144. And 3 3s are 9. We can write 90 as 2 into 3 square into 5. 144 as 1 2 3 4 1 2 3 4 2 to the power 4 into 3 square. Now HCF, okay, HCF and LCM. Now see. Now what you do? Exactly the same way as I have done in the previous sum. You write down 90, 144. Now tell me what are the prime factors you find here. Just leave the power part. Leave the power part and just see what are the prime factors used here. It's 2, 3 and 5. 2 and 3. Now see, when you are finding HCF, just try to, remember what we have done in the previous sum. What we have to do here is find out which is a common factor. It's 2 and 3. So write down 2 into 3. Write down all the prime factors used here in both the case. What are all the prime factors you can see here? You can see that in both the case and both the numbers, the prime factors used is 2, 3 and 5. Okay. So write down, don't repeat the prime factors. Write down all the prime factors which you see here. Okay. Next. When you are finding HCF of two numbers, in HCF what you have to do? You have to take the least power of 2 in both the numbers. In both the numbers, what is the least power of 2? It's 1. What is the least power of 3 in both the case? 2. So 3 square is 9, 9 2 is 18. So 18 is the HCF of these two numbers. Means what? If you divide 90 by 18, it will be completely divisible and the remainder will be 0. If you divide 144 by 18, 144 will be exactly completely divisible and the remainder will be 0. What about LCM? In LCM, what you have to do is check the greatest exponent of 2 in both the case. The greatest exponent of 2 in both the cases is 4. So it's 2 to the power 4. The greatest exponent of 3 in both the cases is what? 2. So it will be 3 to the power 2. And here you have 5 to the power 1. So we have 2 to the power 4, which is 16. 3 square is 9, 9 5 ja. 3 square is 9, 9 5 ja, 45. Multiply. Okay, so we have 720. Now, so this is the way how we find out HCF of two or more positive integers. Now just try to see one thing. When you are finding, HCF and LCM of two positive integers, there is very interesting, one relationship between HCF, LCM and the two numbers. Just try to see everyone. You will find that if you multiply HCF of these two numbers with the LCM of these two numbers, which is 720, you will find that the product of HCF and LCM of two numbers only, make sure, is always equal to the product of the numbers itself. The product of the numbers itself. That is, just note down. HCF is how much? 18. LCM is how much? 720. And this is 90 into 144. Let us multiply. So we have 9 4 are 36, 9 4 are 36, 39, 3, 9 1 are 9, 10 11, 12. 1 to 9, 1 to 9, 6, 0. Clear? Next. Now 720 into 18. So we have 8 2 ja 16, 1, 8 7 ja 56, 57, 1 2 ja 2, 1 7 ja 7, 6, 9, 12. So we have 1 2, okay? We have 1 2, 9 6, 0. Clear? So what we are finding, if you have two positive integers, make sure that product of HCF and LCM is always equals to the product of two numbers whose HCF and LCM we have calculated. Clear? Make sure that this is very, very important. Okay. Now let me just generalize. Okay. Let me just generalize that we can say that if you have suppose two positive integers, that is A and B. If you have two positive numbers, that is A and B. So we can say that HCF into LCM of these two positive numbers is equal to A into B. Now we will see the application of this observation, that is HCF into LCM is equals to A into B. Make sure that two numbers, and let us apply this in solving one question. Okay, so I'll be taking the second question where I'll be using that LCM into HCF of two numbers is equal to A into B. I'll be using this. Now let's take one sum. And the question is, given that HCF of two numbers, if in the bracket you write down 306, 657, what do you mean by this? It means that the HCF of these two numbers is given to you, which is 9. And the question is, find LCM of these two numbers, that is 306 and 657. This is the question. Now we all know that, so what is this answer? Now see everyone, let us assume these two numbers as one as A, any one as A, other one as B, that is 657, and the HCF of these two numbers is known to us, which is how much? 9. So without finding LCM by using prime factorization method, what we are going to do here in this sum is, we are going to apply this observation, that is observation made when we have two integers, not more than 2. And what is that? HCF of two numbers, okay, suppose if you have two numbers, then product of HCF and LCM is equal to the product of two numbers. Okay, product of LCM and HCF is equal to the product of two numbers. And what are those two numbers? We know here. HCF is known to us. LCM we don't know. What is the LCM? What is the value of A? It's 306. What is the value of B? It's 657. So what will be LCM? It will be 306 into 657 divided by 9. So let us simplify and see what is the answer. So we have 306 into, it will be simplified and it can be written as 73. Okay, just note down 9 7 are 63 and 9 3 are 27, 73. Now let us multiply. So we find that the reduce, if you simplify this, we find that we have 306 into 73, and if you multiply, we have 3 6 are 18, 3 3s are 9. Then we have 7 6 are 42. 7 3s are 21. So the number is, and the result is 8. 2 plus 1 3. 13. 2 2. So it is how much? We are finding that LCM of two numbers is equal to 2 2 3 3 8. So what we have done here in this sum is we have calculated LCM of two numbers 306 and 657 without applying prime factorization method and using this relationship that HCF into LCM is equals to A into B. Now in the next link, okay, everyone just go to the next link. You will find we are going to use the application, we are going to apply HCF and LCM of two numbers or more than two numbers will apply in problem sums, okay. So in the next link, we are going to see the application of HCF and LCM of two or more numbers, okay. So everyone just click to the next link and we'll see the application.